How is a bond's price related to its yield to maturity? We're going to analyze this very special relationship in quite a bit of depth in the days ahead. But today, I'd like to just start off with the very basic aspects of the relationship. And I'd like to do that with an example. In this example, we're going to take a look at a specific bond, and from the contract, as we've done before, we will be able to quickly get to a timeline of cash flows. And so we'll draw that timeline, and then we will move into a valuation formula. And so that's going to look like just a basic bond pricing equation. Now, from that point, we're going to take a few different scenarios and show how either price or yield to maturity changes. One way we could go about this is look at three different values for yield to maturity and solve for the price under each. The other way we go about this is look at three different prices and for each price solve for the yield to maturity. Either way, we get a picture of this relationship, and since we've already spent a bit of time calculating prices, I'm going to focus our efforts on this second method. Here I've written down a set of characteristics from our example bond, and so again, you could think of these as being taken straight out of the bond contract, and these numbers should look familiar to you because they are the same ones we used in an earlier example. And so this bond has 10 years remaining to maturity, a 4.25% coupon rate, and as with most bonds, semi-annual coupon payments and $1,000 par value. And so we can immediately say from these first three statements that we're going to have a timeline that contains 20 periods. And that's because we have 10 years, but semi-annual coupon payments, so 10 times 2 is 20. And the annual coupon amount is the coupon rate times par value, which is $42.50. But recall these payments will be made every 6 months, and so it's going to be half of that each 6 months. And so our semi-annual payment is going to equal 1/2 of $42.50, which equals $21.25. So we can take this information and move straight into a timeline. And as we already pointed out, this timeline needs to have 20 ticks. The coupons, again, will show up at times 1 through 20, and then the par value repayment will occur at time 20. And so now we can write our basic bond pricing formula as the present value of an annuity plus the present value of the lump sum par repayment at maturity. So the present value of the annuity is the payment times an annuity factor. And the present value of the par repayment is just the single cash flow discounted 20 times. Now, notice that we still have two unknowns, a price and a discount rate. And so we have the ability to insert one of these and solve for the other. So either I can insert a discount rate and solve for price, or I can insert a price and solve for a discount rate. And so in this example, I'm going to give you a few different prices, and we're going to solve for a few different discount rates under those situations. I'm going to make a little chart here. To describe our three scenarios. And so we'll keep it pretty simple here. Well, for three different prices for this bond, one is $1,100, one is $900, and one is $1,000. And so for each of these scenarios, we want to solve for R. And then we'll take that value of R and translate that to a yield to maturity. And then I'm going to leave some room here for comments. All right, scenario one, price equals $1,100. So if you set price equal to $1,100 and then run this through either your financial calculator or through an Excel spreadsheet, and I'm not going to show you those steps right now because I do that in another video, so you can refer back to that if you need help. But if you set price equal to $1,100 and set the other values as they should be, and back out the R, or the discount rate, you'll get a value of 1.54%. So what's yield to maturity? Well, recall that since we're dealing with a semi-annual timeline, the R that we find is a semi-annual discount rate. Yield to maturity should be an annualized value, so we're going to double the R to report the yield to maturity. And so double the R gives us a 3.08% yield to maturity. Now contrast that with this scenario 2 where price is $900. So if price is lower and nothing else changes, what's going to happen to yield to maturity? Well, we know from our time value of money mechanics that there is an inverse relationship between present value and the discount rate. So if nothing else changes, make present value go down, the discount rate has to go up. It's purely mechanical. And so if you plug in $900 as your present value here, or your price of your bond, you'll see exactly that. And so the R that you find in that scenario is 2.78%. And to report that as a yield to maturity, we're going to double the value, and we'll report 5.57%. And finally, scenario 3, where price is $1,000. And so again, insert 1,000 into the price, and we can expect to get some number for yield to maturity in between the 3.08 and 5.57%, because 1,000 is between the prices of 1,100 and 900, and we see that that again is the case. So the R that we find is 2.125%. Double that for a yield to maturity of 4.25%. Now let's make some comments here. And before we do that, a couple of things that I want to remind you of are, first, the par value of the bond is 1,000, and the coupon rate is equal to 4.25%. Let's think of the par value as a loan amount and the coupon rate as the loan's interest rate. Let's also think of the yield to maturity as investors' required return. And finally, the price as the market value of the loan. Now look at scenario 3. We notice two things. First, the coupon rate equals the yield to maturity, 4.25%, 4.25%. And second, the price equals par, $1,000, $1,000. Why is that the case? Well, the interest rate of the loan is the same thing as whatever investors require. And because the interest rate is the exact same as what investors require, people are willing to buy or sell this loan in the secondary market for exactly the loan amount. Now look at scenario 2. What's different? In scenario 2, we have a coupon rate that is below the yield to maturity, right? 4.25% coupon, 5.57% yield to maturity. So what are the implications of that? Well, we've got a loan that has an interest rate that is smaller than investors actually require. And so the interest rate is smaller than what investors require. They're not going to pay as much for this in the open market, and that's exactly why we see the price less than it was in case 3. And so we say this bond sells at a discount. $900 represents a discount to the $1,000 par. And finally, scenario 1, we have coupon rate greater than the yield to maturity. 4.25% is greater than 3.08%. And so we've got a loan where the interest rate is actually more than investors require. And so what are investors going to do in the open market? Well, they're going to be willing to buy or sell this loan for more than the loan amount. And that's exactly why we have a price of $1,100, which is in excess of the par value of $1,000. And so we would say that this bond sells at a premium. That is, the price of $1,100 contains a premium over the par value of $1,000.